All right. This video is for number 5, which is, I believe, all of the area problems. And then number 12, because we've already done all the vectors and all the triangles. All right. Find the area of a triangle. The formula you use depends on what you have. In this case here, when you have side angle side like that, you've got to use I don't even remember what it's called. Is it Heron's? I don't know. You got to use the one where it has sine of the angle. So half times side times sine 48. That is what you do. So 0.5 times that. So the area is about 297.26. What are we dealing with? Feet. And it's area, so we write a little 2 for 2-dimensional. So when you have a side, an angle, and a side like that, that's the formula you use. You use this guy here. The next time that happens is in part D. D also has, this is 102, this is 16, and this is 20. And it has 2 sides and the included angle and the angle in between them, just like part A. So this here, you're going to go 1/2 times 20 times 16, sine 102, do bloop, bloop, bleep, bloop, 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 bloop. And that's about, area here is about 156.5 meters squared, because it's area. All right, sometimes you don't have an angle. Sometimes all you have is all 3 sides. When all you have is all 3 sides, we use a lot of bit different formula. We got 6, 16, and 18. So we have no angles, so we can't use what we've been using. This is one where you have to find that value of S. And what S is at the sum of all the sides divided by 2. So 16 plus 8 plus 6 divided by 2 is, what? Oh, 18. Okay, oh my God, it's 20. S is 20. Now, once you have S, you're going to write this really big square root. And this is 4 things go under it. One of them is S. And you're going to multiply these 4 things together. The next thing is S minus one of the sides. And then you've got S minus the other one. And then you've got S minus the last one. And when you and then you just throw that into a calculator, like the square root of all that stuff. And when you do that, you should get 47.33 meters squared. This guy here, same deal. It doesn't tell you what is what, but that's fine. All right, same thing. You find S. S is where you add up all the sides and divide it by 2. In this case, you're going to get 479.5. This one's a pain in the butt because there's a lot of numbers. What you're going to type into your calculator is the square root 479.5 times 479.5 minus one of the sides, times 479.5 minus another side, times 479.5 minus the third side. And when you type that all into your calculator, you're going to get about 35,314 I can't read this, 8252. I don't know. I'll write down what they wrote. There you go. Feet squared. That's the area of that. You're going to want to know those area formulas. Don't forget them. And then all we have left on this guy is this. I don't know. These are kind of goofy. Just because they're just asking you to study. You don't have to like work a problem. You're not going to really see this. Law of cosines is this. The equation to find the angle between 2 vectors is you dot product the vectors and then multiply it or divide it by the product of their magnitudes and then inverse cosine them. When do you use law of sines? When you have an angle side pair. So you have A's or your B's or your C's. Heron's formula is, it's this one. This one is called Heron's formula. I don't care if you know the name of it. I just care that you know how to find S, which is adding up all the sides and dividing them by 2. And I care that you know when to use it. When they're asking for area and all you have are side lengths. How do you find out if 2 vectors are orthogonal, parallel, or neither? I like to find the slant / slope and compare them, but also orthogonal vectors have a dot product of 0. How do you determine if 2 vectors are equivalent? There's two things that has to happen. They have to have the same magnitude. They need to be the exact same length. And they have to have the same slant slope. Rise over run. All right. That's all I know. Bye.